Welcome to class today. Today I'll be doing a quick revision on certain topics that usually come out in the NECO exams. For those of you that are preparing for the NECO exams for physics, so there are certain topics that they must always come out, and you need to understand these topics. So I'll take time to talk about those topics. I'll be talking about topics like light, optics. I'll talk about lens. I'll talk about mirror. I will give you a shortcut that you can use to know how to answer questions on lens and mirror. So stick around to the end of this video. I'll be talking about electricity. I'll be talking about elasticity. I will talk about expansivity. I will talk about projectiles. Those are some of the topics I will be talking about. I want you to stick around. And for those of you that commented on my last video telling me that that video was quite helpful, I want to appreciate you. Thank you very much for dropping your comment. It's quite encouraging, and we are encouraged to keep releasing content that will help you do well in your exams. Do not forget, if you have not subscribed to our channel, to subscribe right now and share this video with your friends so they can also get value from this video. Thank you. So the first thing I'll talk about in this class, I'll be talking about lens and mirror. This question says, list the properties of image formed by a plane mirror. Number one. So list the properties of image formed by a plane mirror. Now I'm going to use this topic to talk about light and optics. I will talk about plane mirror. I'll talk about convex mirror, or curved mirrors rather. I'll talk about curved mirrors, and I will talk about lenses as well. Now, let's talk about mirror. The first thing you need to talk about when we talk about light, light is a form of energy, luminous energy, okay? That is light energy. And the first point you need to know, they can also ask you to define certain terminologies. So the first terminology is ray. What is ray? Ray is a path or a direction through which light energy moves. It's a path that light energy, or a path through which light energy moves. Better still, a path through which, let's put it that way, a path through which light energy moves. That's a ray of light. What is a beam? A beam is a combination of many rays. So what is a ray? What is a beam? So if I have let's say I have a curved mirror, have a mirror like this. This light ray that enters into it, this is a light ray. It's the direction or the path through which light energy travels. So this is a ray, right? But when I have combination of rays, I have many rays, have other rays, okay? Together, they are called beam of light. Beam. So here is beam of light traveling into this mirror. That is the first thing you want to know. The next thing we need to know is this. Let's talk about a plane mirror. Now, if you stand in front of a mirror, okay, you want to maybe rub powder for the females or for the males before you go out of the room. You want to just check up yourself in the mirror. Now, what is a mirror? A mirror is an optical material. Before I define mirror, let's talk about what a transparent material, a translucent material, and opaque material is. They can ask you to write on that. So when light travels through a material, and that light can go through that material to the other side, okay, that is what you call a transparent material. And because of the light being able to go through, you can see the other side, all right, through that material. For example, glass. If you have a glass, you can see the other side of the glass because light rays can pass through. So that glass is said to be transparent. All right. Now, when I have paper, or I have maybe tissue paper, all right, and then if you look at tissue paper, you see that yes, you can. There's a little level of vision that you can see the other side to a level, meaning the amount of light that passes through it is low compared to that of glass. And because the amount of light that can pass through it is low, okay, you can just see faintly or just minimal vision through it. That kind of material is called translucent. So I've defined the first one, transparent. Transparent material is the one that allows light to pass through it. Then you have translucent. Translucent is the one that allows just small amount of light to pass through it. Little amount of light pass through. Transparent, light passes through. And because light passes through transparent, you can see through. Because little amount of light passes through translucent, there is a limit to what you can see. And the last one is opaque. An opaque object is one that will not allow light to pass through it at all. Light will not pass through it at all. So because light will not pass through it at all, you cannot see the other side. You can't see through it. Example is the wall. The wall. So if I look at the wall, because light cannot pass through, I cannot see the other side of the wall. So that is an opaque material. Opaque, light cannot pass through at all. Good. Now, I'd like you to pause this video and you will quickly do an experiment in your room. If you have a glass in your room, try to stand in front of the glass and view yourself. You will see that you cannot see yourself inside that glass. You cannot see yourself inside the glass. Rather, you can see the other side of the glass. But take a book and place it behind the glass and try to view inside it again. Place a book behind that glass. Okay, open the glass, place a book behind it, and then try to view. You will see that you are seeing your image in that glass. Why are you seeing your image in that glass? Because now that glass has now become a mirror. It has become a mirror. All right, and that practical will help you to easily remember the definition of a mirror. So a mirror is an optical material that will not, all right, that has at least one surface painted or coated. That is a mirror. So I can define a mirror is an optical material. Optical has to do with light. Optical material with at least one, or not, it doesn't have to be at least, with one surface painted. With one surface painted or coated. So it could be silver plating, it could be silver that is used to coat it, it could be a darkish paint, but it has to be painted. So that painting is now an obstruction. It's an obstacle to the light that is passing through. So because of that obstacle, the light that is trying to enter that glass will now bounce back. So the bouncing back of that light is what will make your image to be formed on that glass, and that is what mirror is. So that bouncing back of light is what you call reflection. Reflection is when light coming from a source bounces back to the source as a result of obstacle in the surface that the light is directed towards. Are you with me now? So because you remember I told you to place a book behind the glass, because the light cannot go through, it has to bounce back, and then your image is formed there. So that is how you see yourself in a mirror. So a mirror is an optical material with one surface painted or coated. For a mirror operates on the principle of reflection. So a mirror, that is another question you could be asked. A mirror operates on the principle of reflection. A mirror operates on the principle of reflection. So reflection means the light cannot pass through, it bounces back. So if you want to define reflection, reflection can be defined as what? You can define reflection as the bouncing back of light rays. Bouncing back of light rays to its source. When it falls on a surface as a result of an obstacle or obstruction. As I've always said, there are scoring points that the examiner is looking for. So you don't need to cram what is in your textbook. Once you understand the concept, you'll be able to put it in your own language. There are certain things the examiner is looking for, scoring points that will earn you the mark. So when you say bouncing back, that is reflection, back to its source, where the light is coming from, and then it falls on a surface, bounces back, and then as a result of an obstacle in that surface, you have captured your scoring point. I hope that is clear. That is reflection. So the next thing we want to talk about is, let's talk about the types of mirror. We have defined mirror. We have spoken about the principle that operates a mirror. What are the types of mirror? You can have plane mirror, you can have curved mirrors. For the plane mirror, what are the properties of, so they can ask you to list the properties of image formed on a plane mirror. Then property of image formed on convex mirror, concave mirror, which are the major types of curved mirror. So let's talk about that. Let's list the properties of image formed by a plane mirror. Number one, if you stand in front of a plane mirror, you see that you are having exactly the same size as the image you are seeing. So they have same size. So same size as object. Number two, you see that if you go close to that mirror, your image will come close. If you come close, it comes close. If you take a step back, it goes a step back. So take a step back. As you are going further, the image is going further. So that means the same distance from the mirror. The image has the same distance from the mirror as the object. Do you understand? Or object distance from the mirror and image distance from the mirror are the same. So image and object have same distance from the mirror. Next, I've discussed same size. The next thing, when you raise your right hand up in the mirror, you see that in the mirror, it's going to be the left hand. That is what you call laterally inverted. So it is, the image, it is laterally inverted. It is laterally inverted. What more? It is a virtual image. It's a virtual image. What is a virtual image? A virtual image is an image that is formed when light cannot pass through. Light cannot pass through the image. Light cannot pass through that object, and then the image is cast. So it's a virtual image, not a real image. A real image, light can pass through and then it's formed. So, but for a virtual image, light cannot pass through it, and then a virtual image cannot be captured on a screen. It cannot be captured on a screen, while a real image can be captured on a screen. So what you have in a plane mirror, okay, is virtual. It's a virtual image. It's not real. It's a virtual image, same size as the object. Image and object have same distance. It is laterally inverted. It is virtual. It is virtual. One more. Finally, it is upright. Upright or erect. Now, having said this, the next thing I want to talk about, let's talk about a curved mirror. Because I wouldn't want to go into details because of time, I promised to give you a shortcut. So I'm going to do a shortcut on this board of how to know image formed by a concave mirror, concave lens, convex mirror, convex lens. Are you ready for that? Now, before I talk about that, it's important to know what is a lens. A lens is an optical material with at least one surface curved. At least one surface is curved. So it can be the two surfaces that are curved, okay? It could be one surface curved. When two surfaces are curved, you can have a biconcave, biconvex mirror. If one surface is plane, the other is curved, that is a plano-concave or a plano-convex. So a lens is an optical material with at least one surface curved. It operates. So a lens operates on the principle of what? Refraction. Refraction. It operates on the principle of refraction. Unlike the mirror that operates the principle of reflection, a lens operates the principle of refraction. So what is refraction? Refraction is the bending or the change in the direction of the light ray, all right, because of changing medium, material medium. What am I talking about? When light is coming from air, is going straight or in a vacuum. When it enters the lens is a glass. So there is a change in medium from light to glass. So once that light enters the glass and is coming out, it's because of the change in the medium, there will be a bending away of that light ray. So that bending away is what you call refraction. That is what you call refraction. That is what you call refraction. So before we continue, let's talk about the laws. They can ask you to state the laws of reflection, the laws of refraction. Laws of reflection, very simple. There are three things you need to know. Laws of reflection. Three things you need to know. Number one, the incident ray. That's number one. The reflected ray. That's second. And the normal. That's the third. At the point of incidence, all lie on the same plane. Don't mind me, I'm checking my microphone because there are times I've done a video long time and the microphone had gone off, and then I just discovered that no sound. So I don't want that to happen, and that is why I have to check from time to time. All right, so the laws of reflection, the incident ray, the reflected ray, and the normal at the point of incidence all lie on the same plane. That is the law of reflection. All right, and then of course the angle of incidence and the angle of reflection are equal. They are the same. The angle of incidence, angle of reflection are the same. What's the meaning of angle of incidence? This line that comes from the source of light or from the object, this line, okay, that falls on this mirror, this is the incidence ray. So, but to make it a lot more clearer, let's do this. Let's have this. So this is the mirror. A normal, this is the normal. Normal is a line that is drawn that is perpendicular to the surface of the mirror, perpendicular to the surface of the reflecting mirror, okay, or the reflecting surface. So this is a normal line. So if I have an angle of incidence falling here, this angle of incidence, then I'm going to have an angle of reflection like this. Reflection means it goes back, thrown back because of the painting here. So when we now say the law, okay, the angle of incidence, the angle between here and this normal is the angle of incidence. The angle between here and this reflected ray is the angle of reflection. So this is my incident ray, while this is my reflected ray. And this line that is perpendicular, perpendicular means it forms angle 90 degrees with the surface. That is the normal line. That's the normal. So when they say the incident ray, reflected ray, and the normal at the point of incidence, this is the point of incidence, the point at which it strikes here, they all lie on the same plane. That is the first rule. And of course, the second rule, if here is 30 degrees, here too is 30 degrees. So the angle of incidence and the angle of reflection, they are equal. Right. Now let's talk about the laws of refraction. So they can ask you to state it. Laws of refraction is as well simple too. All right. All you just need to do is, instead of reflection, reflected, here you put refracted. So the incident ray, the refracted ray, and the normal, the point of incidence, all lie on the same plane. That's the law of refraction. The incident ray, the refracted ray, and the normal at the point of incidence all lie on the same plane. All right. So let's now go ahead, and then of course the sine of angle of incidence over the sine of angle of refraction is constant. That is the second, which is called the Snell's law. That is the second law of refraction, the Snell's law. The sine of angle of incidence, or the ratio of the sine of angle of incidence to the sine of angle of refraction, is constant. Meaning sine I over sine r, sine I over sine r is constant. It's constant. All right? It's constant. That is called the Snell's law. That is the second law of refraction. We've seen the laws that operate the lens and the mirror. Let's now look at that shortcut that you can use to know the image formed by a lens and a mirror. So the first thing you want to show, I'm going to give you an acronym. The acronym I'll be giving you is DriveX. DriveX. Please take note of these mnemonics. Very, very important. DriveX. What is the meaning of DriveX? DriveX, so for you to remember, DriveX means a driver that is vexing. Is that okay? A driver that is vexing. DriveX. So what has DriveX got to do with physics? Very simple. DriveX means for a convex lens. So we are going to start with convex lens. So convex lens, concave lens. So you are going to have to draw four. You have a column, another one here, another one here, another one. Four columns. Preferably let it be under each one. So here, now it's important to note this: whatever is applicable for a lens, the reverse is applicable for a mirror. I repeat, whatever applies for a lens, reverse applies for a mirror. When a lens is converging, that mirror will be diverging. Are you there with me? So the first thing, before we come to this DriveX, the first thing you need to take note of is this: a convex lens is a converging lens. So they can ask you which one is converging. A convex lens is a converging lens. What do I mean by converging convex lens? Look at this diagram. If I have this diagram, this is an example of a convex lens. When light rays enters here like this, all right, light rays enters here, light rays enters here, The law says the light ray will move towards the wider part of this lens. So this is a convex lens. Convex lens. So what part is wider? Is it this poles, not posal pole? Is it this point or the center of the lens? You agree that for this convex is the center that is wider. So the light that enters here, you remember I said the lens operates by refraction, and refraction means the bending or change in direction of the light ray. So there will be a change in the direction of this light ray towards the center, which is wider. This one will move towards the center. Now what has happened here? Light rays that are coming from different places, they came and converged at this point, which this is the image. So if I say in a school, if I say all SS1, SS2 and SS3 students converge in front of the principal's office at the close of school, at closing time, right? It means all of you are coming from your different classes and you are meeting at a point at the principal's office. All right? So that is converging. So we are converging. So this is converge. So the first thing you need to know is that a convex lens converges rays. So a convex lens is a converging lens, right? While this is a concave. How do you remember concave? What is a cave? A cave is a hole. Is a hole. Maybe that is dug inside a mountain, a rock, a hole that somebody can run into and hide, or you can stay there. So look at this. Consider this as a hole. Instead of it to be flat like this, there's a hole. It's caved in. There is a caving in here. So this is a concave lens. So when this is a biconcave lens. This is a biconvex lens. So when you have a caving in, that is concave. So here, when light rays enters here, all right, light ray enters here from the source. Light ray enters here. What will happen? I told you the light will move towards the wider part of the lens. So what part is wider? Is it the center or the poles? You will see that the poles is wider. So this light ray that enters here, it will move towards this part. This one will move towards this part. This one will move towards the wider part, like that. Can you see how they move away? So that moving, that scattering is what you call diverging. So a concave, this is a concave lens. A concave lens is diverging. So concave lens is a diverging lens. That's it. Concave is diverge. So here, you know, I told you this is where the image is formed. Where will the image be formed here? I will need to drag this back. I will need to trace all these scattered rays. I will trace them back. Then the point at which they meet, that is where the image will be formed. Any image that is formed by tracing this back, you remember I told you a virtual image cannot be formed on a screen. There's a screen here. The image will not be formed there. So I need to trace this backward for the image to be formed at the back. So any image formed by tracing back an imaginary line, that image is called a virtual image. It's not a real image. It's a virtual image. So the meaning of that is a convex lens will form a real image, while a concave lens will form a virtual image. Now let's now go back to properties of image formed by convex lens and concave. Convex is converging, concave is diverging. Now, what is the meaning of diverge? It means for a convex lens, not mirror, please. Convex lens, most of the images formed by a convex lens are D for diminished. So most are diminished. What is the meaning of diminished? Diminished means it reduces in size. It will be smaller. R means real. They are real. Real. Can you see convex lens, real image? So they are real. Then high means they are inverted. Inverted. They are inverted. So most images. Now, depending on the distance, are you with me? Depending on the distance, there could be a little change here. But majorly, most, no matter the distance, for most of them, they are aligned with this. Therefore, your concave lens, the opposite of convex lens is what you have. So the opposite of diminished is magnified. So this is magnified. The opposite of real is what? Virtual. So this is a virtual image. You see virtual here. Then the opposite of inverted is erect. So, or upright. Please, you can write any of the two. Don't write this or this. You can write upright, you can write erect. They are the same. So these are properties of image formed by a convex lens and a concave lens. Now, let's talk about that of a mirror. For a mirror, you remember I told you, whatever is applicable for lens, the reverse is applicable for mirror. So, for a convex mirror and then concave mirror, the first thing is that, you see, whatever is applicable for concave lens, just copy it here. Whatever is here, copy it here. So that means for a convex mirror, is opposite of what is here, or just copy this here. So a convex mirror is a diverging mirror. Then most times the image form will be magnified, most times virtual, most time upright. While for concave mirror, it aligns the convex lens, so it's converging. Image is converging, is diminished most times, it is real most times, and then it is inverted. Now there are a few exemptions here. One of the exemptions here is that most images formed by mirror, whether it's concave or convex, they are usually virtual images because light cannot pass through the mirror, all right? It is thrown back. So most times they are virtual image, all right? But for the other ones, most of them are correct and you can use them in answering questions. Now, let me give you another example that you can use to practice this in your house to see whether it's correct or not. You can get a spoon, go into your kitchen, pause this video, go to your kitchen, get a spoon, all right, and place the spoon, the hole inside that spoon, that is the concave. Remember, hole is the cave. So point that point. Okay, let me quickly do that experiment for you. And look at this, there is power in pictures. You can easily remember what you have pictured, what you have seen. What is this? This is a spoon, all right? Now, is this a lens or a mirror? This is a mirror because it's not transparent. I cannot see the other side through here. So light cannot pass through, so this is a mirror. That's number one. Number two, this place that is caved in, this portion of this spoon that is caved in is the concave mirror. Why this outside that bulges out? This point that bulges out is the convex mirror. All right. So let's quickly confirm if what we are saying here is actually true or not. Now, when I look at, so you also have to do this experiment. If I look into this place now, which is a concave mirror, the inside the cave, I can see that my head is downward and then my legs are up. So this is inverted for concave mirror. So let's look at it. Concave mirror, can you see inverted? So this is correct. It's inverted. It's inverted. It's inverted. And then at some point, as the distance is going, it's getting diminished. Where this diminish comes in. So as the distance gets farther, it's getting smaller, and then at some distances, it's the same size. But if I point it out, convex mirror, looking at this now, my head is up. That's erect. So convex mirror, my head is up, upright. Convex mirror, upright. So this is correct. Correct. All right? Correct. So you can also do this experiment. It will help you to remember how to answer questions on light in your exams. Now, having said that, the last thing I'll talk about eye defects before I leave this. So they can ask you to talk about eye defect. Number one, you have myopia. Myopia is the same thing as short sight or short-sightedness. What is short-sightedness? Short sight is the ability to see close objects and not distant objects. So this is what you can use to remember. When you say somebody is myopic in thinking, that means the person only thinks about the now. The person does not think about tomorrow. Are you with me? So if I say the noisemakers in this class are myopic in thinking, That means they don't think about the present, they don't think about tomorrow, they only think about the present. All right? So myopia means you can only see close objects, you can't see farther objects. That is myopia. Ability to see close objects but not distant objects. How do you correct it? Before we talk about how to correct it, now this short sight, the eyeball is too long or too large. Eyeball is too large. Why do they say the eyeball is too large? So let me draw how the defect, how it looks like. Number one, note that your eyeball is not circle. Your eyeball is not circle. It's oval, but then it has a bulging at the frontal part. That is how your eyeball looks like, okay? And there is a lens inside your eye. So this is the light from the source coming into this eyeball. So I said the eyeball is too large, so they can ask you to draw this diagram and the corrective measure. When the eyeball is too large, then it means the image forms in front of the retina. So they can draw this diagram and ask you, what kind of eye defect is this? It is short-sightedness. Why? So for short sight, eyeball is too large. For long sight, eyeball is too short. Are you with me? So here, eyeball is too large because this is the image forming here. Normally, the image is supposed to be formed on the retina. This is the retina, which is the inner layer of the eyeball. So, but the image forms in front of the retina. So here, eyeball is too large, all right? Image form in front of retina. So how do we correct it? We need a lens that can push this image, push this light ray that is converging here, push it forward, so that once it pushes it, it can land on the retina. So what do you call that pushing light ray? Or that lens that has the ability to push? It is a what? Concave or diverging lens. Concave or diverging lens. So it is corrected using concave or diverging lens. So a concave or diverging lens that is introduced here, we push these light rays, push it further and allow it to land on the retina. While for long sight is also called hypermetropia, not hypermyopia. They can write that in the option. Hypermetropia. Hypermetropia is long sight or long-sightedness. What is long-sightedness? Ability to see distant objects but not close objects. Ability to see distant objects but not close objects. So long-sightedness means the eyeball is too short. Because the eyeball is too short, all right, the image is formed behind the retina. So here, eyeball is short. Eyeball is short. Image formed behind retina. All right. So this is for short sight. This is what will happen. The image will now be formed here behind the retina. So when you see a diagram like this, the eyeball is too short. This is what you call long-sightedness. Long-sightedness. Okay. So this long-sightedness, because the eyeball is too short, an image is formed here, we need a lens that can compress the light ray that was coming, the intensity of the light that was coming, compress it before it enters this eyeball, so that it will not be going farther away from the retina, but it can land on the retina, and that is a converging or convex lens. So hypermetropia is corrected by convex or converging lens. Full stop. I hope that is clear to everybody. So I'm going to stop at that point and then we go to the next topic because of our time. I hope you got value. If you have gotten value on this, go to the comment section and type in DriveX, type in whatever acronym or that you've learned from here. Eyeball too large, eyeball too long, myopic in thinking. You can just type it and type value. And let's go to the next topic. The next one I'll talk about is projectile. So for projectile, they can ask you, what is a projectile body? A projectile body is a body that is launched into here that moves in a parabolic shape, like a parabola. Okay, it's an object launched into air that has both vertical and horizontal components. Example is bullet of a gun that is shot, a stone that is thrown, and then a tennis ball that is launched or played. Now, there are 4 different formulas they can ask you to ask. They can ask questions on and ask you to solve in part A of your physics. They can ask you to calculate time to reach the maximum height, time of flight, then maximum height reached, then the range. So I'll quickly give you a shortcut formula you can use to know them. The first one is time to reach maximum height. Time to reach maximum height is small t, and that small t is u sine theta over g. U sine theta over g. Number 2, time of flight. Time of flight is capital T, and the formula is capital T is 2u sine theta over g. I will talk about that. Number 3, you have the range. The range R is giving us u squared sine 2 theta over g. U squared sine 2 theta over g. That's your range. Your range is the horizontal distance covered. Horizontal distance covered from the point where the object was launched to where it's landed. Time of flight is the time it takes the object to go up and to come down, or when the time between launching it and then it landing. That is the time. And the last one is the maximum height. What's the formula for maximum height? Maximum height, H max, is giving us u squared sine squared theta over 2g. U squared sine squared theta over 2g. Now, what's the maximum height? So look at this. If you look at these 3 formula, something is common. There is something I want to show you here. If you look at the time to reach maximum height, how many 2 can you find here? There is none. How many 2 can you find here? 1. How many 2 can you find here? 1, 2. How many 2 can you find here? 1, 2, 3. So the first thing you need to note is that for these 4 equations, there is a particular formula that does not have 2 at all. There is one that has 2 occurring once. There is one that has 2 occurring twice. There is another one that has 2 occurring 3 times. Clock that. The next thing is this. The maximum height has the maximum amount of 2's. The maximum height has the maximum amount of 2, which is what? 1, 2, 3. So 2 is appearing 3 times here, and that is the maximum height. While for this one, the time to reach maximum height does not have a 2. Now look at it. Your capital T is 2 of small t. That's another thing to take note of. Your capital T, which is your time of flight, is 2 times small t. So all they did between here and here is they just added 2 to your u sine theta over g, and it becomes 2u sine theta over g. All right? And for here, this your sine 2 theta. Please take note. This sine 2 theta is the same thing. Sine 2 theta is the same thing as 2 sine theta cos theta. Now, of all these equations, the only place where cos theta will be mentioned is range. Why? Because cos theta talks about the horizontal component. The horizontal component of force or velocity. So, the only place where you have sine 2 theta in this equation is range. And that sine 2 theta simply means 2 sine theta cos theta. If you punch this in your calculator, make theta maybe 30 degrees. Sine 2 times 30, that's sine 60. Then press 2 sine 30 cos 30, you will see they're exactly the same thing. So range is where you have sine 2 theta. Every other place, here you have 2u sine theta over g, so u squared sine 2 theta over g. Then here you have u squared sine squared theta over 2g. The meaning of sine squared theta is when you find your sine of the angles. Let's say the angle is 30 degrees. Sine 30 is 0.5. You square that 0.5. That's the meaning of sine squared theta. Is that okay? Then they can ask you, at what angle do I need to shoot this gun to be able to get to the highest range, to be able to get to the highest vertical height? They can ask you that question. You can say A, 30 degrees, B, 45 degrees, C, 90 degrees. Now, if you look at sine 30 is 0.5. So no matter what I have calculated here, if I multiply sine 30, no matter the amount of my u, sine 30 will break it down. So here, if I use sine 30, that's half of whatever I've calculated here. But sine 90 is 1. Sine 90 is 1. So how can I get 90 for here? The range. Range is the horizontal distance covered. How, at what degree do I need to shoot my gun to be able to travel the fastest range? It is 2 times what will give me 90 degrees. It is 2 times 45. So it's 45 degrees. Because sine 2 times 45, that's 90. Sine 90 is 1. All right. So if sine 90 is 1, yeah, sine 90 is 1. All right. 1 times whatever I have here, I will have the highest number. But if I use sine 30 or sine 60, it will reduce the number here. Are you getting what I'm saying? The meaning of that is it is at angle 45 degrees that the highest range will be covered. So maximum range will just be u squared over g. Why is so? If they say what's the formula for maximum range? Maximum range is what? U squared over g. Why? Because this 2 times theta will be 2 times 45. That will be sine 90. That's 1. So u squared over g. I hope that is clear. Now